All right, it is 10 o'clock Pacific. Welcome, everybody, to the first episode of Hack Summer. Let's get this show on the road. To start off, my name is Michael Taggart, or just Taggart. I know too many Michaels in my life to expect my first name to get used, so Taggart's just fine. You can find me on Twitter, if you haven't already, here at MTTaggart. And I want to talk a little bit about why I'm doing this and where we're going to go. So these days I work in cybersecurity. I'm an analyst for a pretty large healthcare organization, and I love my work. I get paid to protect computer systems and break into computer systems to try to protect them more. It's a great job. I really, really love it. But I didn't always do this, right? I actually started in education. I was a tech director for schools. And so I built networks, I deployed devices to students, but I was also a teacher. And actually my formal education is in education, and an English degree. But with that background, I really loved teaching, and I taught myself programming for the needs of my work at that time. And it was a real joy to be able to pass that knowledge on to other people. And so in this new line of work that I found myself in for the past couple of years, I love what I'm doing, but I do miss teaching. And right now, there are a lot of students of all ages who are a little bit less active than we would hope, right? And opportunities to learn are a little bit restricted because we're all staying at home more. And so I was hoping that we could create a space for all of us to learn a little bit more and have some fun over the summer. And so, Hack Summer. So what we're going to be doing first and foremost is we're going to be exploring the Python programming language. And I want to talk for a minute about why Python. So there are a lot of different programming languages you can learn, and there are a lot of different approaches to learning how to code in general. So why Python, right? It is not the language that, as a high school student, you're probably introduced to in an AP Computer Science class in the United States. And that's actually good news for us. I think that the AP Computer Science course is a little bit flawed in the way that it introduces folks to programming. Python is what we call a general purpose programming language. It's not designed for one thing. You can use Python for lots of different applications. You can build web applications with it. You can build games with it. You can build web servers with it. You can build hacking tools with it, which I do kind of on a regular basis these days. So because of its versatility, it's a really, really valuable language to learn. That's one. Another reason why I think Python is really important to learn is, especially as a first language, is its clarity. We'll talk more about the syntax of programming, all of the pieces that go into writing proper lines of code. With Python, it's very readable. Its use of strange symbols, curly braces, semicolons, things like that is pretty minimal. And so when the code is more readable, it's easier for new programmers to get into it. So we're going to be using Python. This is designed for folks of all ages, right? But there are some not really learning prerequisites, but some ability prerequisites that you're going to need in order to follow along with us. And if you're not ready for that, that's okay. Basically, in terms of prerequisites, you're going to have to be able to type, okay, and read the code. So this course is in English. I know that we have some viewers from around the world. Hopefully, your English is okay, and that's going to be necessary for us to proceed. And if you're a younger student, we're going to be typing out code. So your ability to type should be okay. It doesn't have to be great, but make sure that as we type code together, you're paying attention to what you're typing, because simple mistakes can get frustrating. We'll talk a little bit more about how to handle that in a little bit, but those are the two prerequisites. There are no knowledge prerequisites. We're going to assume that everyone is starting from a place of zero knowledge about this material. So if you've never written a line of code before, that's fine. We're going to teach you, you're going to write your first line of code today. You're going to become a programmer today. And in terms of the other material that we're going to be covering, also, we're going to start from a place of zero assumptions about knowledge, and we'll explore things together. So the other theme about this material and this course, Hack Summer, is going to be cybersecurity. I'm really passionate about it, and I think it's a great way to learn technology through sort of the extremes of what we can do with it. A lot of cybersecurity is about how to understand technology in a fundamental way and understand how it can be used in ways that aren't intended. And that's really the definition of hacking. We'll talk a little bit more about hacking versus crime, but when we engage in hacking, we are putting pieces together in unexpected ways. And with cybersecurity, a lot of what we do is making sure that our pieces are put together in safe ways, and that when there is a vulnerability, which is a flaw or a misconfiguration in a system, when somebody can use it in an unexpected way, we want to know how to exploit it so we can test for it, and also how to protect against it. So we'll be talking about those ideas in cybersecurity, and in fact, we'll be using Python to explore more of these ideas about how to protect systems and how to ethically explore vulnerabilities in systems. That ethically is really important. We don't want to break any laws here. So inside of those concepts, inside of cybersecurity in particular, we're going to be focusing on networking, how computers communicate with one another, and how the internet is put together. Those basic concepts are going to be really, really valuable for us. And even if you've never set up a home Wi-Fi network or anything else like that, we're going to explore those concepts, and we're going to do it using Python and later some other tools as well. So again, this is a course that assumes no knowledge. This is a safe space to learn. We'll also play around with some concepts in cryptography, right? Keeping secrets secret, and we'll be using Python to build encryption and decryption tools and learn some of the rules that we have about cryptography in security, like why do our passwords need to look a certain way, or what really is a strong password. We'll be exploring those things as well. Another piece of the cybersecurity puzzle is OSINT, or open source intelligence. And this is a research skill, right? Open source intelligence is material that's freely available for us to learn about an organization or a person and learn how there might be security vulnerabilities for that individual or for that organization. We're going to learn how to use OSINT to kind of do reconnaissance on a target or a research subject. And we're going to learn how to use Python to make a lot of that process faster. If you have any questions, feel free to drop them in the live chat. I am watching it, so if I'm missing something, or you have any questions, please feel free to drop them in there. In addition to the material I've mentioned so far, we're going to cover other things. We're going to cover items of interest that come up for us as we explore this material together. Hopefully, as the course goes on, I won't be the only voice that you hear on here. Hopefully, we'll have some guests with expertise outside my own. And I really hope that I learn a lot through this adventure too. So in terms of scheduling, we're going to be here every day, or every Saturday at 10 a.m. Pacific, right? We're going to be doing this stream every Saturday. In terms of how long it goes, we're definitely going to run this until the end of September. So beyond that, I'm not really sure. I call this Hack Summer in part to put an end to it. But if there's interest in moving forward after that, we will explore that. If this is your first exposure to programming, or your first time really trying to learn to code, or maybe it's not, maybe you tried before and it didn't really work out for whatever reason, I want to talk a little bit about the experience of learning to program and why it's so difficult in general, and some encouragement for how to move forward and how to succeed. So I taught myself how to program. I didn't have a lot of guidance. The resources that are available for folks today were not available for me so much. I had edX, MIT courses to learn Python, and before that I learned PHP on my own. it was a little bit more difficult, and I know what it's like to be struggling with a new concept and not have a lot of support, and in particular to feel like you're just bad at something. When I was in school, I was a terrible math student, right? And it was just sort of assumed that I was bad at math. Yeah, it turned out that that's not true. Bad at math isn't really a thing. What's true is that people's cognitive abilities develop at different times, and it doesn't always work out for school's schedule. So as I got older, my quantitative reasoning kind of came of age, but it wasn't on time for the failing grade in algebra that I got in 8th grade. So be kind to yourself if you've had kind of a rough history with some of this material. That's one. The second is a lot of being bad at something has a lot to do with how it's been presented. I was a teacher for a long time, and I've seen a lot of bad teaching. I've seen a lot of great teaching too, but I can't tell you the number of times I've seen students get discouraged just because material wasn't presented well, right? Especially in younger ages. There's some good research about how people can get discouraged because a teacher has a distaste for a subject, and that is transmitted in their instruction. So if you've struggled with this material before, forgive yourself for that and recognize that this is something that you can do despite that. One of the hardest things about programming when you're teaching yourself how to program or you're learning alongside is that, especially when you're getting started, most of the time you're getting it wrong, right? It's very frustrating. You're going to be making a lot of mistakes at first, and it's going to feel really, really hard. It's going to feel discouraging to always find an error in your code, that it doesn't run immediately or it doesn't do the thing that you want it to do, and you spend most of your time finding your own mistakes. That can be really humbling. It can be really, really discouraging. I want to call that out now so that we put ourselves in the right mindset for exploring this material. You are going to make mistakes. That is okay. You have to make mistakes, and in fact, learning how to deal with them and then learning how to read error messages and debug your code, that's, I think, one of the most important skills a programmer can have. So just know that you're going to make mistakes. It's going to feel really difficult, especially at the beginning. That is okay. That's part of the learning process. By no means does it suggest that you are bad at this or that you can't do it. You absolutely can do this. I have never met a student of any age who absolutely just could not code, could not program. It's all about approach. It's all about finding the way that it clicks for you. So I encourage you, even if you're struggling at the beginning, to keep with it, right? I promise that if it's something you really want to do, you can. And hopefully you'll learn to love it. I really struggled with it when I started. I had to because of the work I was doing. And I fell in love with it. And I fell in love with it not as a kind of mathematical, scientific experience, but as a language, right? I think that it's beautiful that we can express logical ideas in this form, and we can do real things for real people with it. And that's actually an important point. At the end of the day, this is a skill like any other that we can use to make the world better, right? And that's ultimately what we want to do. We want to try to make things, we want to try to fix things so that we can help others. That's a big point for me. And it's also why, as we go through, the tools that we'll be using are freely available or open source, so that there is no financial limitation to what we're doing. At the end of the show, I'm going to ask for a donation, not to me, but to either a cause of your choosing or one that I recommend that helps bridge the digital divide so that students and families have access to technology regardless of their socioeconomic status. Everyone's heard the term hacking. And because of today's media, it has a really negative connotation. When you hear hacking, you think of, a guy in a Guy Fawkes mask in a hoodie, right? Click-clacking away, breaking into systems and disclosing data, or, bringing down an important system. It's really discouraging. It's really disappointing to me that that's what hacking has come to mean. Hacking is not a bad thing. Hacking is a form of creativity. It is taking commonly observed or commonly used items and putting them together in unexpected ways, or thinking about things in new ways, right? I don't love the word innovation because I think it's overused, but hacking and innovation in some ways are synonymous. It really is about putting things together in new ways. You think about Steve Wozniak and Steve Jobs cobbling together the first Apple computer in their garage. That was hacking, right? You think about the scientists at UCLA and UCSB and Cal State putting together the first computer network. That was hacking. Hacking is good. Cybercrime is bad, and that's what we want to avoid. We want to avoid being criminals. And that's when we use the skills of hacking for malicious ends. We're going to absolutely stay on the ethical side of things, and I can't encourage you enough to do that yourself. We want to know what the risks are in computer systems, and we want to know how they can be vulnerable so we can protect ourselves and others. It is not so that we can do crimes. You may have heard the terms black hat, white hat, gray hat when it comes to hackers. Essentially, a white hat is a hacker who uses their skills for good, protects systems, and finds vulnerabilities responsibly, discloses vulnerabilities responsibly, and reports them and helps to fix them. That's white hat. That's us. A gray hat is kind of, they're trying to do the right thing, but they're not asking permission. And depending on whom they're trying to help, it can be taken the wrong way. And their regard for laws is a little bit less than is appropriate for helping in a responsible society. And then a black hat is just a bad guy. Okay, it's somebody who doesn't care about the laws, really wants to break in, and they may in fact be sponsored by a nation to do so, or an organized crime group. So that's not us. We're going to have white hats on for the entirety of this course. All right, that's enough of me just talking at you. Let's get coding. We're going to use an online platform to start in this course because I want to make sure that everybody has easy access to get started. So we're going to use Replit. You can sign up for an account. It's totally free at repl.it. You can sign up with a Google account or whatever else you like, but that's what we're going to start with. And Replit is great because it's an online platform that allows you to experiment with many different kinds of programming languages. Python is one of them, and that's what we're going to use it for, at least at first. But it's just a really great platform. I've used it in teaching before. So that's where we're going to start. So I'm going to give a tour of Replit, and as I'm doing so, feel free to go sign up for an account if you haven't already, or just sign in with your pre-existing Google account or Twitter or whatever else they allow you to sign up with. All right. So here I am over in Replit, and I'm logged out. So this is what you should see, as well as me. And I'm just gonna click on login. You're gonna click on sign up if you haven't done that before. I'll sign in with Google. And here is the homepage for Replit. So over on the left-hand side, you have some different templates and tutorials. Replit is a community, so there are other REPLs. REPL, by the way, stands for Read, Eval, Print, Loop. And that's a common concept in programming, and we'll actually see a REPL when we get started with Python. We're going to click on this button, create a REPL Python, but you can also see that there's a My REPLs section over here. And if I go into that, you can create folders. There's also a multiplayer mode we might play with a little bit later in the course, where multiple people can actually collaborate, like on a Google Doc, on one piece of code. I have a Hack Summer folder, I'm going to go in here and I'm going to just make a new REPL here. You might want to make a folder as well, just to keep things organized. I like to keep things organized. And you can see that there are a lot of languages that are available in Replit, right? Python, Node.js. Some of these you may have heard of, some of them you may have not, like Scheme or Rust, Haskell, which is a favorite of mine. But for now, we're going to stick with Python, our good old friendly noodles. We click on Python, and it'll make a random name for the REPL. If you like it, cool. If not, feel free to rename it. So I'm just going to make Hacksummer Hello. All right, and create REPL. So you can share the link with others if you want. I'm going to zoom this in just a little bit. It's easier to read for folks. All right. That'll do. Okay. So I'm also going to change to dark mode. Yes, excellent. Okay, so quick tour of Replit in the actual coding window. So on the very left-hand side, you have some options for how to manage the REPL. So imagine that there's a folder on your virtual computer here, and by default, we have the main.py, which is our Python file. That's where we're going to write our Python code. .py is the extension for Python code files. Then we have version control, which is like the history of changes to your code. We'll talk about that a little bit later in the course. Packages, so we can add plugins to Python to extend its capability beyond the base language. We'll be using that later as well. And then a debugger. Again, we'll play with all of these, but just know that these are different options for controlling our programming environment. Then we have our file section. We can make folders and files, text files, other Python files, right in here. And again, it works just like a folder on your computer. And then on the left-hand side of our programming screen, we have our code window. You can see there's a tab here that says main.py. We can have more than one tab open, and it will autosave. Over on the right-hand side is what we can call either the Python shell or the Python REPL. And essentially, rather than writing a file of code and then clicking run, what we're going to see here is that we can actually just test lines of code one at a time over on the right-hand side. So we'll play with that in just a second. Just moving my notes over. All right, so time to write our first Python instruction. Okay, we're going to write it over in the right-hand side, so over here in the REPL or the Python shell, and we're going to write print parentheses, quotes, hello world. I am kind of a traditionalist when it comes to things like this, and this is what you need to write when you first start learning a programming language. This is the traditional first program. So once you type that, click enter or type enter, and you'll see that hello world comes back. Now, it might seem pretty simple, but there's a lot going on here that we need to understand. The first thing is we just wrote a Python statement. This is the first instruction. A statement is like a sentence, right? It has to be complete. And it is something that we tell the computer to do with code. Now, this statement was a command. We use the print function. Now, print needs some extra information. It needs to know what it's going to print out. So we have to give it the text, hello world. In order to tell Python that it is text and not something else, we have to put the text inside of quotes. You can use single quotes or double quotes, but you need those quotes. If we were to try it without quotes, we will get an error. So let's try it without quotes and see what an error in Python looks like. Okay, so it says invalid syntax. There's that syntax word. So syntax is just a fancy way of saying we typed something improperly, right? The language did not recognize what we were trying to say. So we need those quotes in there, and just to demonstrate it, it does work with single quotes as well. Okay. Now, let's come over to the programming window, the code window, and try it in here and see what the difference is. So we do print. The first thing you should notice is that it's a little bit easier to type. Those parentheses will get completed for you, and we'll also get some hints about what we're doing and some documentation from Python about what the print function does. Don't worry too much about this right now. We haven't explored Python enough to really gate value or take advantage of this information, but just know that when we do start typing functions and Python recognizes it, we'll get this hinting for what we're supposed to do next. But we can see the thing that we need to put in there is the value to print. So let's go ahead and print hello world. Okay, we'll do it here. So a couple of things to notice before we go any further. Notice that we have some coloring in our code. So we're going to see this to help us understand what we're doing in Python. The code editor is going to help us by highlighting functions. It's going to help us by highlighting text. And it's even going to highlight the parentheses to help us identify where the parenthesized things begin and end. Now, nothing showed up over on the right-hand side, our output. This is our input, this is our output. But we haven't gotten any output yet from our code. Why is that? Because we haven't clicked run. So let's click run and see what happens. All right, so the REPL resets, and then we get the output from our program. So this is our Python program. It's one line, but it works. Now, real quickly, because I want everyone to understand what's going on at a little bit of a deeper level, I want to talk about what's happening when we click run. That code that we wrote is not what the computer actually understands natively. That code has to be taken and interpreted into a different language that the computer understands. And it's interpreted at a couple of different levels, right? And eventually becomes a series of zeros and ones, as you may have heard about, that computers can only understand zeros and ones. Well, those zeros and ones are instructions that the computer's processor, or central processing unit, uses to do the math that relates to our program. And even though we're working with text here, even though we're working with words, at the end of the day, everything is described with numbers in a computer, right? And even the instructions to print things out, that's all numbers. So we can eventually represent all of these as numerical instructions. So I just wanted to make sure that we understood that's what's going on when we click run, that there's this whole process taking place to translate our human readable instructions into computer readable instructions that look way different. All right, let's play around with some other kinds of instructions. So one of the things I really like in the Python REPL is that we can do some math. It works like a calculator. So let's try some basic math here. We've done print, but let's try doing some basic math. So we can do 3 plus 3, right? That gives us back an answer. So that's addition. 3 minus 3. We can also go into negatives, so we do 3 minus 6. We can do decimals, we can do what we call floats, right? 3.0 plus 5.4. Okay. We can do multiplication with the asterisk. We can do division with the /. Notice, interestingly, that we get, even when we give it whole numbers, we get back a decimal when we do division. That's an important thing that we'll be talking about, right? And if we do 10 divided by 3, you might notice something a little bit funky going on. We should know that 10 divided by 3 is 3.33 repeating, right? There's just an infinity of 3's after that. But because of the way that Python interprets those non-terminating decimals, those decimals that go on forever and ever, the last decimal is going to be wrong. So just be aware of that. It's one of the fun things about computer science, is that in many ways computer science is not exact, right? Often computer science is the science of close enough. And so we have accuracy, we have precision up to this decimal point, right? Or this place. But after that, we lose it. And a lot of that depends on the kind of computer that Python is running on. But just be aware that some funny things can happen at the extremes when we do computer science like this. We can also do exponentiation. So if I do 10 asterisk 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 2, we'll get 100. So we can do exponentiation that way as well. So we've got the full suite of basic mathematical operations. There are others as well that we can do, but that's good for a start. We can also do comparisons. So this is really, really fun. So let's try saying 10 is greater than 2. Notice that it doesn't return a number, it doesn't return text, it returns a new kind of thing. It returns true. Let's flip that comparison around. Now we're going to say 10 is less than 2. It gives us false. True and false are called Boolean statements. Boolean statements are named after George Boole, who was an English logician who came up with a whole system of logic based around truth and falsity. But it's important that evaluating things as true or false is like core in programming. So we're actually going to play with that next. Well, almost next. There's one other thing that we're going to do first. Coming back over here into our code window, we're going to learn another instruction type. So we've seen how to give a print instruction, right? But we're also going to learn about comments and variables. It might go without saying, but I want to make it explicit that a computer program, and especially a Python program, runs like a recipe, right? We read it from top to bottom. So as the instructions proceed, that's the order in which the instructions will execute. So if I had 2 print statements, in order, what we're going to see in our output is hello world first and hack summer next. Okay? So just be aware of that. The order of your instructions is going to be the order of execution. Now, sometimes we might want to put some notes in our code about what the code does. And for that, we use comments. In Python, we have 2 ways of making comments. The first way is for a single line comment, and that's by putting a # or a hashtag before the line. So put the hashtag down and say, notice that it turned green. The Python interpreter, which is what takes our code and turns it into 0s and 1s and then executes it, is going to ignore lines that have a hashtag at the beginning. So again, it reads this line, skips it, and then goes on to lines 2 and 3. Now, we have this text, right? This greeting text, and that's cool. But imagine if we wanted to greet a little bit more creatively. And imagine that we wanted to have maybe somebody's name that we use again and again. Instead of constantly, typing out that text as it is, we want to save that information somewhere. So to do that, we need a variable. A variable in algebra is a number that we don't know, right? But a variable in computer programming is a little bit different. Think of it as a bucket where we can put information. So we can store a value in a variable. That information can take lots of different types. We've already seen 3 different types of information, right? We've seen text information inside of quotes. We've seen numerical information, right? Like a 3 or a 5.4. And we've seen true and false, Boolean information. There are others which we'll cover, but those are kinds of information that we can store in a variable. So let's learn how to create a variable. We're going to create a variable called name, and we just write the name, and then we use the single equals sign. That's really, really important. A single equals sign has a very special meaning in programming, and in Python in particular, that is different from what you're used to in math. Okay? An equal sign in math is a comparison or a statement that 2 things are equal. But that's not true here. An equal sign in programming is an instruction. What I'm doing with the single equal sign is what I always like to refer to as AVV, or assigning a value to a variable. And I do it with an equal sign. So what I'm doing with this equal sign is saying, hey, this text, Taggart, now lives inside this variable called a name. And instead of using that text again and again, I can actually just refer back to that variable and it'll run it. So take a minute just now before I click run. I want you to make some predictions about what the code that's going to execute actually looks like. Making predictions about what your code is going to do is a really important skill, because then you'll know when it's not working. Okay, so hopefully what you predicted was that we're going to see hello world, hello hack summer like before, but then we're going to see just my name. Or your name if you put your name in. You can put whatever you want in. It's your code. And that's exactly right. Now there's one other thing that we can do here that's pretty rad, which is called string concatenation. Concatenation is taking 2 strings and putting them together, smashing them together. Over in the right hand side, let me show you what this looks like. If we take the string hack and use the plus sign, summer, and combine it with the string summer. String is what we use for text data. That's the term for that. So if we use that plus sign between them, what we're going to get back is a combined or concatenated string. So we can actually write something like hello, comma, space. That's going to be important for readability, plus name. And if we want to be even more excited about it, let's put another plus in there and put an exclamation point in there. So you can see that that's why the comma and space before the end quote for hello was so important. If I didn't have that, it would have looked a little bit funky, right? It would have run into my name. That's no good. There are other ways of creating combined strings like this in Python, but this is, I think, the important way to learn first. So that's string concatenation. Okay. Now, this is cool, but it's a little bit limited, right? Because we can only greet the person whose name we put in the code. Thank you for putting up the vocab words, EscapePod87. I would also add string in there. But, so this is a little bit limited, right? Because we can only greet the person whose name we put in the code. What if we had a way to get information from the user as the program ran so that we can get their name, ask their name, and then greet them directly? So we're going to combine input and output here in the program. Well, we can do that. So that's our next command that we're going to learn. We know about print. The next one we're going to learn is input. So rather than assigning name to a static string like this, we're actually going to assign it to the result of a function. Let's use that function first to see how it works over in the right-hand side, and then we'll use it over in the left-hand side. So input we give input a string with a prompt because that's what's going to be provided to the user to get information back. So check that out. Notice that I don't have the little 3 square prompt right now because the input function is currently running. It's asking me for my name. So if I give it my name and press enter, it returns, it gives back, produces that value. So what I can do is I can take this function, right, just like this. I might put a space after the question mark just because it looks a little bit funky, that close together. But I can take exactly this and put it, let me copy that text, and put it on the right-hand side of my assigning value to a variable, my AVV here. What's going to happen then, and yeah, put that space there so that it's a little bit easier to read, is that anytime I run this program, 3 things are going to happen. First, it's going to print out hello world. Then it's going to print out hello hack summer. And then, well, it's going to ask my name first. First and foremost, it's going to do that. Then it's going to print hello world hack summer. And then it's going to print whatever name I give it. Let's give it a try. Dope. All right, so we have string concatenation and we have successfully gotten input from the user. Quick understanding check. What kind of information? We've talked about different kinds of information. Strings, we've talked about numbers, we've talked about booleans. What kind of information is coming back from the input function? Going once, going twice. So that's string information. And that's true even if we give it a number. So if we ask, like, what's your favorite number? And I give it 42. Notice that the 42 is in quotes. So just be aware of that. We'll actually run into this in the next thing that we do, because we're going to have to convert this string into a number. Yep, so just know that input always brings back a string. That's really, really important in Python to remember, because if you are trying to do math with a string, you'll get really funky results. For example, watch what happens when I do 42 times 3. It actually creates 3 instances of that and concatenates them together. And if I were to try to do 42 plus 3, I should just get an error. Yeah, and it tells me can only concatenate string, not integer to string. All right. So we have our name. We're getting input from the user. Let's prevent lines 5 and 6 from executing. We understand that they're doing printing. That's useful, but and I don't want to delete the code. I might want to use it later, but I don't want it executing. So how could I prevent these lines from executing but still keep the line of code? If you said comment out the line or add a hashtag to the beginning of it, you're absolutely correct. So you can do that a couple of different ways in Replit. You can just manually type it out, right? Or there's a keyboard shortcut, which is Control/, and you can actually highlight or Command on a Mac, Control/, and you can actually do that for multiple lines. So if I highlight more than one line and do Control/, whoops, it'll comment both out. Even if the coloring gets weird. I'm not sure why I did that. It's funny. It's just a comment, Replit. There you go. Okay, so now it's just going to print out the concatenation of hello and the name. But what if we wanted to have different output depending on what the name was? For that, we're going to need to learn the second important construction in core programming. We've already learned the first, which is variables. The second is a conditional. So code that conditional is a little bit difficult to explain briefly, but I want to try. So a conditional is a test, and the test has to be something that can be said to be true or false. If the test is true, then the code inside the conditional runs, and then we can add other conditions attached to it for other situations. So very, very simply, an example of a conditional is, and actually I'm going to show you, for this, I'm going to show you the different way of making a comment in Python. This is how you do multi-line comments. 3 quotes and combine it, and contain it inside 3 quotes. So anything inside here is not executed as code. Okay, so if you want to have multi-line comments in your code, put 3 quotes at the bottom and top, and you're good to go. So, plain English conditional. If it's sunny, I'll go to the beach. What has to be true in order for this person to go to the beach? It's got to be sunny, right? Only if it's sunny will they go to the beach. And, hopefully they'll be socially distant and they will, not sit in one place. They won't be within 6 feet of other people, and they'll be wearing a mask. That's not conditional. They just have to do that. Let's make it a little bit more interesting. I was going to say go to the movies, but ain't nobody going to the movies right now. Otherwise, I'll play video games. Okay, so now we have 2 possibilities, right? Before it was just like, they'll go to the beach or they won't. But now, if it's sunny, they'll go to the beach. But if it's not sunny, we now know that they'll do something else. Something else. Right? Where they'll play video games. We can describe these kinds of situations in code, and we'll do it in Python with what we call if-else statements. That's the conditional in Python. So, let me clean this up just a little bit here. This is perfect. We're doing well on time. This is where I wanted to end today. Okay, So instead of, we're going to comment out the print hello name because we just want to get the name, and then we're going to do something different depending on the name. Okay, so we're going to say, we're going to do something special if the name is Hack Summer. Okay, if name, now we already said that a single equal sign has a special meaning. That's AVV, that's assigning a value to a variable. But we can use two equal signs to do a comparison between two sides. So over here, real quick, if I said 10 equal 10, that's true, right? If I said 10, if I said 10 equal 9, that's false. Okay, so for comparisons, just like we did the greater than, less than, the equivalence is two equal signs in Python. So we can say if name equal Hack Summer, colon, that's super important. That's our first really special character in Python that we've seen. Really, really important. And then when we press enter after the colon, you're going to notice that the next line of code is indented. That's important too. Python doesn't use curly braces or anything like that to set off sections of code, but it does use colons and then indentation. So if your indentation is wrong, your code won't run the way that you expect. So just be aware of that. So if name equals Hack Summer, any suggestions for what we should say? Just be like, oh yeah, for now. Hopefully there will be some suggestions come in, but that's what we'll do if the name is Hack Summer. Otherwise, we could just leave it there, right? And then if the name wasn't Hack Summer, nothing would happen. But otherwise, we could say print the name and hello. So we do an else, right? And inside that else, we'll use that string concatenation that we did before. Oh, I like it. Life is good. All right, we'll do that. Okay, so if name equals Hack Summer, we're going to print life is good. Otherwise, we're going to print hello name. So when we run this, we get the what's your name, right? So I'll just put in Taggart, and I just get my name. Cool. But if I run it again, and I put in Hack Summer, and it's going to be case sensitive, I get life is good. So our conditional is working. We've now changed up the flow of the program, right? Rather than just going in a straight line from top to bottom, we can kind of take detours, right? Depending on whether this test is true or false. Let's add one more piece of it. So let's have a second condition. So elif is a little bit of a, kind of just a programming shortcut. It's a combination of the words else and if. So else if. So we're gonna make this. We're gonna conduct this test first. We're gonna see if name is Hack Summer. If it's not true, we move on and we'll conduct this test. So if the name equals Python, we'll print you're a good noodle. Okay. So now we have a proper conditional statement, right? We have an if, we have one test, we have another condition that might be true. When we have an elif in there between the if and the else, we have to have the else. So you can have an if by itself, you can have an if and an else together, but you can't have if and elif and then nothing. If you have an if and an elif, you have to have an else. You have to have a default that happens if the other two tests are false. Okay, so if we run this, right? Let's try that. Let's try, so just confirming Hack Summer still works. My name still works. And then Python works as well. Now, hopefully everything's clear so far. If there are any questions, please feel free to drop them in the chat. But it seems a little bit contrived, but what if we changed this up a little bit to be something like username, and then we did another one of these, and we're like password. This is basically how authentication works. This is what happens at a very fundamental level when you log in to a computer or to a website. It's not all happening in Python. There are different languages, and your password isn't just like stored somewhere in plain text. Well, hopefully, sometimes it is. But at the very basic conceptual level, what's going on is your username is combined with a password. It's related to a password, and a computer conditional statement just like this is testing to see whether your username exists, whether the password is correct, and if it matches what's in the system. And if it does, then you're logged in. If it doesn't, then you don't get logged in and you get an error. We'll play a little bit more with that kind of idea next week, and we'll actually make a game next week that uses conditionals a little bit more interestingly. But let's pause here and just kind of take stock. So I want to thank you first for joining us today for our first episode, and I also want to congratulate you. If this is your first time programming, congratulations, you're now a programmer. No one can say otherwise. You're a programmer, you're a hacker. You have successfully written a Python program, and you have understood some really fundamental concepts in computer science and computer programming. So congratulate yourself. I'm really proud of you. There's a lot more to do. We're going to have a lot more fun in the coming weeks, but we're off to a great start. As I said at the beginning, if you're finding value in this and you'd like to give back in some way, I'm not going to ask for any compensation for myself. I would like you to take that desire to give and to donate to a cause that is worth your hard-earned money. There are a lot of great causes out there. Hopefully you're moved to give to one that increases justice in the world. That's at the end of the day, that's kind of why I'm doing this, is that more people should have access to this skill, right? I believe that it is a core literacy for the 21st century, that we all understand how computers work at this level. And I think it's a matter of justice, that everyone should have the ability to learn how to do this. And because everyone should have the ability to learn how to build technology in this way, everyone should have access to technology, which is why I'm recommending, if you don't have a cause in mind, Human IT. Human IT is a nonprofit organization that gives access to low-cost internet connections and also computing devices to families in need. They do great work. They're a really well-established and well-regarded nonprofit, and they'll take donations of money or old computers if you have them. They'll refurbish them. They'll give them to folks who need them. You can find them at humanit.org. And so if that's of interest to you, then absolutely consider giving to them or another charity of your choosing. But thank you so much for joining us. I hope you've enjoyed the first episode of Hack Summer. We will be here next week on Saturday, 10 a.m. Pacific time. Thanks for joining us.